Hello everybody, differentiation tutorial time. So today we will be differentiating polynomials. But first of all, what is differentiation? Differentiation is when you have a function, say f of x, and you find the amount it's changing, or the rate of change. When you have a function, its rate of change is denoted as f prime x, which notice the apostrophe. Oh, hello. Notice the apostrophe. Now, if you have a thing, say y equals kx, right? To know how much the kx be changing, where k is just a constant, you would put dy by dx, so you're differentiating y with respect to x, so the thing that you're doing the maths to is the x, and like that's just that, is equal to, well, in this case it'd be k, and I'll explain why later. Now is later. We are differentiating polynomials. That is, if we have x to the 4 plus 3x cubed plus 2x squared. This is, actually, let's make it nice and put a 4 there. Realistically, you can have anything. However, polynomials are things where you have a coefficient of x raised to a power plus coefficient of x raised to a different power. Now this coefficient could be 1 or it could be 0. So in this case you could have plus 0x plus 0, but you don't need to do those because 0. Right? Now the rule here is that if y is equal to x to the n, dy by dx is equal to n times x to the n minus 1. As an example, y equals x cubed. Pause the video and find what dy by dx is. The answer is 3x squared, because 3 is n times x, n minus 1 is 2, so it's 3x squared. Now, the other thing to note, if we have a coefficient, so y equals kx to the n, dy by dx equals kn x to the n minus 1. So, therefore, if we have 4x cubed, dy by dx, have a go yourself, is equal to 12x squared. Lovely jubbly. Now, I'm going to give you 3 questions and I want you to have a go at them. So, y equals 12x squared. Y equals 9x cubed. Y equals 14x plus 192x to the 57. You may need a calculator for that last one. The answer to that... Actually, no, I'm getting rid of that 192. I need to do these ones. Answer for the first one, dy by dx equals 12 times 2 and 2 minus 1. So 24x. Dy by dx equals 9 times 3 is 27. 3 take away 1 is 2. So 27x squared. And now the other thing to note, which I've neglected to tell you, is that if you add 2 things together, say if you have, let me just turn the page. If you have y equals kx to the n plus, or k1 to the plus k2 x to the n2, right? dy by dx is equal to d by dx k1 x n1, or x to the power of n1, plus d by dx k2 x to the n2. The thing to note here, I have not told you what d by dx is. That's differentiating, but without saying y is equal to something. So if you just had the expression 3x squared, d by dx, 3x squared equals 6x. Now, with the 14x plus x, let's see, 14x plus x to the 57, dy by dx equals 14 plus 57 x to the 56. Lovely jubbly. The other thing to note is that these are not fractions. You can't cancel out the d's to make y over x equals 14 plus 57x to the 56. That does not work. That is illegal, quite frankly, and I'm not having it. However, they do behave a bit like fractions, but that's very weird in some cases, most notably the chain rule. We are now going to do differentiation from first principles. This is understanding why differentiation works. Now, to understand why differentiation works, we must first understand what differentiation is and what the process is. So, if we think about it, if we have a straight line, say y equals x, then the gradient would be 1, because y equals mx plus c, c is 0, and m is 1. Because the coefficient of x there is 1, it's just we haven't put it. So we know the gradient's 1. And if we found the rate of change of that using differentiation, dy by dx, that is effectively 1x to the 1. Now, 1 take away 1 is 0, and 1 times 1 is 1, so it is 1x to the 0, which is equal to 1, as x to 0 is 1. So therefore, the gradient of a line, or a straight line, is the same as it differentiated. Now, if we had the curve, say, y equals x squared. Great, we have got y equals x squared. We actually, no, I'm going to have f of x equals x squared, because that makes it easier for what I'm about to show you. Now, if we have point x here, right, the point is f of x. The y point is f of x. So in this case, it'd be x squared. Now, if we wanted to find the rate of change, or the gradient, we could find another point. So I'm going to call that x plus h, and f of x plus h. Now, the change in y over the change of x. So first of all, let's work out the change of y. F of x equals x squared. So therefore, change of y is equal to x plus h squared minus x squared. Change of y, x, right, x plus h minus x, which is equal to h. Lovely. So therefore, the gradient equals x plus h squared minus x squared over h. However, you don't use m when you do this properly. However, I'm just finding the gradient of that. So if we said h was 2 and found it 2 away, x plus 2 squared minus x squared over 2. X squared plus 4x plus 4 minus x squared over 2. We can cancel those out, these x's out, to get, or cancel those out to get 4x plus 4 over 2, 2x plus 2. So, if we say the original x point was, say, 2, the change would be 6. So, from 2, 4 to, 2 plus 2 is 4, 16. Change would be x, substitute x into that, as I said, 6. Now 16 take away 4 is 12, 4 take away 2 is 6, and 12 over 2 equals 6. I think I might have misspoke there, I can't remember. Oh well, that makes sense. Now, let's say, now, we want it to get closer. We want to find how much it's changing each time, and we'll get a more accurate thing if h is equal to 1, right? So, let's have this again, x plus 1 squared minus x over 1. So, we can just kind of cancel that 1 out. So, x squared minus x squared, because I'm putting that there, because we know that cancels out, plus x plus 1. Therefore, if h is equal to 1, the gradient is equal to x plus 1. Say, if we add 2, 4 again, and 3, 9, we know x is, x in this case would be 2, so changing that is 5, that's 1. Right, okay, it's going to be 2, I was a bit of an idiot there. So gradient's 2x plus 1, substitute 2 into that, that's 5. Yes! Now, to find the true result, we want h to be equal to 0. Let's think about that. X plus 0 squared minus x squared over 0. Now, let's ignore the divide by 0. Maybe something will happen there. We know that factorises to x squared minus x, expands to x squared minus x squared over 0, 0 over 0. Oh dear. Golly gosh. That's bad. However, we know that we just want h to be 0. So if we put this a new thing called a limit in, lim h to 0, so as h approaches 0, we can have x plus h squared minus x squared over h. How nice. Now, let's do a bit of algebra on this. We know that this is not possible as h is 0, but we've got that in the limit. So, lim h to 0, let's just expand that. X squared plus 2hx plus h squared minus x squared over h. We have got limit h to 0. If we make that nice and make that one, which isn't on camera, whatever, that previous one nice and neat, you can cancel out the x squareds and just make it 2xh plus h squared over h. Now that's quite clever, especially when we consider we can just cancel out the h's and have 2x plus h, substitute h is equal to 0, 2x. Therefore, the d by dx x squared is equal to 2x, and we know by the previous rules that that's true. We have just done that from first principles. Now, this isn't just something you can work with x squared. As we know, this is a formula that will be given to you in the formula booklet, definitely for A-level and A-level further mathematics, possibly in GCSE further mathematics. I don't actually know whether this is required. I've basically never looked at that. And if you're not British, this won't really apply. So f of x plus h minus f of x over h, or lim h to 0. You don't need the brackets there, but I put that there to make it nicer. It can work with other things, so f of x is equal to x cubed lim h to 0, f of x, hold on a minute, x plus h cubed minus x cubed over h. Now I can't be bothered to do that, but I'm assuming that it gets to 3x squared. You guys can expand it and stuff. I'm an incredibly lazy human being, so I won't be doing that. The final section of this video is learning a proof of the original formula we learnt using first principles. Now, this isn't taught at any of the qualifications that before university. I don't know about university, but say A-level, A-level further, and GCSE further maths. But it's something that I made. Don't know whether it's the most universally accepted proof, but it's definitely a proof. So I'm teaching it. I think it's quite cool. And that is, if we have f of x equals kx to the n, where k is just any old coefficient, and x to the n is any power, right? Then we first of all do lim h to 0, k x plus h to the n plus kx to the n, no, minus, sorry, over h. Good. Now, this is where we may get a bit stuck, as we don't know how to expand something where we don't know the power it's raised to. Or don't we? Then you may or may not know the binomial expansion. This entire proof is basically based upon the binomial expansion, but it is, and if you don't know it, you might be able to work out some of the stuff, but it's a lot easier to understand if you know the binomial expansion. And we know, or may not know, but whatever, if you have x plus h to the n, it is equal to x to the n plus n1 x to the n minus 1 h. I think that's it. So x to the n minus 1 h plus n2 x to the n minus 2 h squared plus nr x to the n minus r h to the r until you get to h to the n, right? That's binomial expansion. That is like proved and stuff. So if we have the limit h to 0 of multiply, so kx to the n plus, that is effectively any old number, because binomial coefficients get you a number in return. However, like, they might be difficult to calculate number. Learn about binomial coefficients. I won't go over the definition here. K n1 x to the n minus 1 h and so on, with this just multiplying each term by k over h. Now, we are subtracting minus that, so I should probably put minus k x to the n. I do not have room. Just imagine that's neat and stuff. Right, so we know those will cancel. So limit h to 0, k n1 x to the n minus 1 h plus k n2 x to the n minus 2 h squared, so on over h. Now, what we can do is cancel those h's, right? So, like you do prior. So, still in the limit h to 0, k n1 x to the n minus 1 plus k n2 x to the n minus 2 h and so on, or so on, plus k n r x to the n minus r h r minus 1. That's jolly well. Very good. Now, if we substitute h is equal to 0, we know that term will be equal to 0. Every one of those terms will be equal to 0, apart from that original term, because that one hasn't got an h in, and when you multiply by h, so we know that is k n1 x to the n minus 1. Now, oh, hello. Binomial coefficients, I may have neglected to say that, but nr equals n factorial over r factorial n minus r factorial. Right? So, we know that it's k n factorial over 1 factorial n minus 1 factorial x to the n minus 1. Right. We know that's just equal to 1. So we have k n factorial over n minus 1 factorial x to the n minus 1. K times n minus 1 factorial over n minus 1 factorial, because that's just factorial x to the n minus 1. So we can cancel those out, and so we now have kn x to the n minus 1, which is a rule. Very cool. Yeah.